Good morning, everyone. Yeah, very good morning. Shall we begin the session? Today's topic is the recursive query. In the last class, we have finished one of the topic, that is the triggers. That is a statement that is executed automatically whenever SQL is executed. Next part is the recursive query. So suppose, recursive query is basically CLE like this. This is a CTE, that is a common table expression, that is a temporary name result set derived from a simple query and defined within the execution scope of our select, insert, update or delete statement. And CTE, that is a common table expression, can be thought of as alternative to the derived table, that is a subqueries, views and inline user defined functions. So it can either be used with the alternatives to the derived tables. It can be either used as a views and the inline user defined functions. That can be of the expression, that can be of the execution scope of a select, insert, update or delete statement. And the CTE, that is a common table expression, is a temporary named result set that is derived from a simple query and defined within the execution scope of a select command. And it is a kind of query in which the DNS server, that is a domain name server, a domain name system server, which will receive the query, will do all the jobs of fetching the answer, that is from the server end, and giving it back to you. During the process, the DNS server or DNS server might also query another DNS servers in the internet on your behalf for the answer. That means we are using the DNS server for the query on the DNS servers on the internet. Now, next question arises, what is a DNS query? So it is a process of computer networking device making an inquiry to get an IP address from the DNS name. So one is the DNS name, one is the IP address. So deriving the IP address from the DNS name, such as w3.org, and the client computer will send a DNS query to one of their internet service providers, that is the DNS service. So it is the process of the computer or the networking device making an inquiry to get an IP address from the DNS name. Now, come back to this one. So suppose now if I want to find out the courses that are a prerequisite, whether directly or indirectly, for a specific course, say CS 347. So we are going to find a course that is direct prerequisite for the CS 347, that is a prerequisite for a course, and so on. And the transitive closure of the relation prerequisite is a relation that contains all the pair, that is a CID pre. So that pre is a direct or indirect prerequisite of the CID. And there are numerous applications that requires computation of the similar transitive closures on the hierarchies. For example, organizations typically consist of the several levels of the organization units, and machines that consist of the parts that in turn have a subparts and so on. For example, when a bicycle have a multiple parts like wheel and a pedal, which in turn have subparts such as the tires, rims and the spoke. So that means whenever we are going into the deep multiple methods, multiple parts, that is known as a transitive. Now, how to use a transitive with the iteration? Alright. Now the next topic is the transitive closure using the iteration. So one way to write the query is to use its iteration and first find those courses that are the direct prerequisite of the CS 347, then those courses that are the prerequisite of all the courses under the first set, and so on. So this iteration process continues until we reach an iteration where no courses are added. So this figure or the function shows the function find all the prerequisites to carry out the task. This function takes the course ID of the course as a parameter, that is the CID. That CID computes the set of the all direct and indirect prerequisite of that course and returns the set. And the procedure uses three temporary tables. One is a C prerequisite, one is a new C prerequisite, one is a tab. So first three prerequisites stores the set of the tuples to be returned. The new C prerequisite that stores the courses found in the previous iteration. Then temp uses the temporary storage while set of the courses are manipulated. So whenever the courses are manipulated, we are using the temp variable. Note that the SQL allows the creation of the temporary table using the command create temporary table, so that the tables are available only within the transaction executing the query. and all drop when the transaction finished. So whenever it is finished, it drops the transaction, it drops the query. Moreover, if two instances of the find all prerequisite runs concurrently, then each gets its own copy of the temporary table. So automatically it gets a copy of the temporary table if they shared a copy, and the result should be incorrect. Whatever the procedure that they follow up, that inserts all the direct prerequisite of course CID into the new C prerequisite before the repeat loop. And the repeat loop first add all the courses in a prerequisite C prerequisite to the C prerequisite. Next it computes the prerequisite of all the courses in the new C prerequisite except that we already found to be the prerequisite of the CID. And finally we replaces or it replaces the content of the new C prerequisite by the content of the temp. And this repeat loop terminates when it finds no new prerequisite. Then figure 5.14 shows the prerequisite that will be found in each iteration in the procedural code for the course that is named CS147, 347. Now this is a function that is a create function, find all prerequisite CID varchar A, then find all the courses, so this will find all the courses that are the prerequisite directly or indirectly for the CID. The next is a return table, course ID varchar A. So the relation prerequisite specifies which course is directly a prerequisite for the another course. Then begin, create temporary table, C prerequisite. Then course ID varchar. So this table C prerequisite stores the set of the courses to be done. Then create temporary table, new C prerequisite, that is a varchar 8. So this table also used with the new C prerequisites that contains courses found in the previous iteration. The next is create the temporary table tab with the course ID varchar. This table tab is used to store the intermediate results. The next part is the insert into new C prerequisite, select prerequisite ID from the prerequisite where the course ID equals to CID. Then repeat, insert into C prerequisite, select the course ID from the new CID and then insert into tab, select prerequisite course ID from the new course or the new C prerequisite where the new C course ID equals to prerequisite of the prerequisite ID. That means two tables are related with each other. So one is a temporary table, one is a temporary table new C prerequisite, then temporary table tab, and insert into new C prerequisite, then repeat, insert into C prerequisite, then select the course ID from the new C prerequisite, then using the tab and selecting the prerequisite course ID. The next step, select course ID from the C prerequisite, delete from the new C, insert it to new C, and select asterisk from the tab, delete from the tab. Then iteration number tuples in C. So one is 0, then 1, then 2, then 3, then 4. Then next is recursion in the C. What are the various methods by which the course ID or by which there is inconvenient to specify the transitive closure using the iteration? There is an alternative approach using the recursive view definition that is easier to use. So we can use the recursive to define the set of the courses that are the prerequisite of a particular course, say 347 of the CS. And the courses that are the prerequisite directly or indirectly are courses for the 347 and courses that are the prerequisite for the 387 or 347. Now next part is the advanced segregation feature that is not in this course. Now next is the OLAP in the SQL, that is online analytical processing. In this we are using the pivot clause in the SQL. No, this is just like a pivot table in the Excel, but the different, this is a different approach we can say. Concept is same, but the syntax is different, logic is different. Yeah, so first name is also same. So multiple SQL implementations such as the Microsoft SQL Server, Oracle supports a pivot clause in SQL, which also allows the creation of the cross tabs. So given the sales relation, we can say the sales table that we say, which allows the creation of the table, which allows the creation of the cross table tabs. And given the sales relation from the figure 5.16, the query select asterisk from sales pivot some quantity for color in dark, pastel, and the whites. So we are using the sum function that quantity will be adding up in which color or quantity of the which color. One is a dark, one is a pastel, and one is a white. Then order by the item name. This is select asterisk from sales pivot some quantity for color in dark, pastel, and the white. Then order by item. This returns the clause tabs shown over here, and then for clause within the pivot clause that also specifies what values from the attribute color should appear as the name attribute in the pivot table. And the attribute color itself is eliminated from the result, although other attributes are also retained, except that the values are changed. Attributes are changed. And in case more than one tuple contributes value to a given cell, the aggregate operation within the pivot clause specifies how the values should be combined, how the quantity values are summed up, how the pivot tables are used up. I note that the pivot clause by itself does not compute the subtotals as we saw in the pivot table. However, we can first generate the relational representation as used in the outline shortly, then apply the pivot clause on that representation to get an equivalent result. And in overall case, the value all must be listed in the for clause, and the order by clause needs to be modified to order all the. And whatever the data that is used in the data queue cannot be generated by a single SQL query using the basic group by constraint or the construct, since the aggregates are computed for several different grouping of the dimension attributes. And for this reason, SQL includes functions to form the grouping needed for the OLAP. And this uses the generalizations of the group by construct to perform the cube and roll-up operations. And the cube and the roll-up construct in the group by clause also allows the multiple group by queries to be run in the single query with the result that is written as a single relation in a style that is just with the relation. To consider again our retail shop example, there's the sales, then item name, color, cloth size, and the quantity. Now we can then find the number of the items sold in each item name by writing a simple group by query. So we are fetching out the item name, and the quantity will be adding out with the sum. So this is sum quantity from sales, that is the sales table. This is the sales table. Now group by item name. So first of all, it is grouped by the item name. Then select out the only the two fields. One is the item name, next is the sum quantity. Yeah, field name is the same, that is the sum quantity. And the result of this query, yeah, this is the output of the query. One is the item name, one is the sum quantity. This is skirt, that is for the 53. One is the dress, that is 35. One is the shirt, 49. Pants, 27. Now, next one. Similarly, we can also find the number of items sold in each color. So in this case, we are also carrying out the color field also for the grouping purpose. And by using multiple attributes in the group by clause, we can find how many items were sold with a certain set of the properties. For example, we can find a breakdown of the sales by item name and the color by writing. So we will select item name, color, some quantity from the sales, group by the item name, color. This is grouped by item name and the color. So select item name, color, some quantity from the sales, then group by item name and the color. The result of this query is shown over here, and note that this represents the same data as it's shown in the first 4 rows and the first 4 columns. And the first 4 rows in the column that are used over here, that is used in representation, that is used in the cube over here. And if however we want to generate the entire data cube using this approach, we would find, or we would have to write a separate query for each of the following set of the attributes. Each query for the each attribute. So this is the output. Item name, color, quantity, one is a skirt, dark, then A, then pastel, 35, then skirt, white, 10, dress dark, 20, then dress pastel 10, white 5, and the shirt dark 40. So it is using out with the pens, then dark 20, pastel 2, and the white 5. So there are 3 colors for the 4 dresses. One is skirt, dress, shirt, and the pant. So this is order by. This is done by using the order by clause. This is item name, color, clause size, item name, color. And the cube construct allows us to accomplish this in one query only. Select item name, color, clause size, some quantity from sales, that is grouped by cube, item name, color, clause size. And this query produces a relation whose schema is item name, color, clause size, some quantity. So that the result of this query is indeed a relation, that is the tuples in the result contains null as a result of those attributes not present in a particular grouping. For example, tuples produced by grouping on the clause size have a schema with a sum quantity. They are converted to tuples on the item name, color, clause size by inserting the null for each item name and the color. So this is a select item name, color, some quantity from sale, that is grouped by cube, item name and the color. And this rollup construct is the same as the cube construct, except that the rollup generates fewer group by queries. And we saw that the group by cube, that is item name, color, clause size, generated all the 8 views of forming a group by query using some form or of the form that is used with the attributes. This is one of the examples. Select item name, color, clause size, and quantity from sales. Now this is grouped by the rollup. And what are the various fields that is coming up? One is the item name, one is the color, one is the clause size. And note that the attributes in the rollup makes a difference, and the final attributes, that the clause size, appears in one grouping, and the second list attributes in the 2 grouping, and so on. Now next is the summary. Just a minute. So take for 5 minutes. Now let's begin with a summary of this chapter. That is the wind up of this chapter. The first point is SQL queries can be invoked from the host language either using the embedded or the dynamic SQL. And there are 2 standards, there are 2 languages that is defined. One is ODBC, Open Database Connectivity, and is a Java Database Connectivity, JDBC. That standards define the application program interface to access the SQL databases, whatever the SQL databases from the C language and the Java language program. And the programmers also use the API, that is the application programming interface, to access the databases. Then functions, and the next point is functions and the procedures can be used or can be defined using the SQL procedure extension that also allows iteration and the conditional if then else statement. The one and the same thing, that is a function and the procedure, that is a predefined using the SQL procedure extension that allows the iteration and the conditional if then else statement. The next is the triggers that defines the actions to be executed. That means what are the various actions that is to be executed within a SQL. So this defines the action to be executed automatically when certain event occurs and corresponding conditions are satisfied with each other. And triggers have many users, triggers have many uses, such as implementing the business rules, audit logging, and even carrying out the actions outside the database systems. And all the triggers were not added to the SQL standard until SQL 1999. Most database systems have a long implemented triggers. So most remote database systems have a long implemented trigger that is used with the database system. And some queries such as the transitive clauses can be expressed either by using the iteration or either by using the recursive SQL queries. Recursion can be expressed using either recursive views or recursive with clauses definitions. The SQL supports certain advanced aggregation features, including the ranking, including the windowing queries, that simplifies the expression of some aggregates and allows more efficient evaluation. So multiple aggregation functions features that includes the ranking, procedure, windowing that requires the expression to be included and that also allows the efficient evaluation. The next is online analytical processing tool that helps the analyst view data summarized in different views so that they can gain insight into the functioning of the organization. The first part is OLAP. That tool works on the multi-dimensional data that is characterized by the dimension attributes and the measure attributes. Then the data cube that consists of the multi-dimensional data summarized in another different ways, and pre-computing the data can also spread up or speed up the queries on the summaries of the data. Then cross tab also displays the format users to view one dimensions of the multi-dimensional data at a time along with the summaries of the data, and drill down, roll up, slice in are among the operations that users can perform with the OLAP tools. These are the features or the advantages of the OLAP. Then SQL, starting with the SQL 1999 standard, provides a variety of the operators for data analysis, including the queue, roll-up operations. Its own system also supports a pivot clause that we have studied, we can say right now, that allows the easy creation of the cross tabs. So one is the review terms, JDBC, ODBC, prepared statements, accessing the metadata, SQL injection, embedded SQL. Now, can anyone define what is the full form of JDBC and the ODBC? Anyone? Yes, very good. ODBC is Open Database Connectivity and JDBC is Java Database Connectivity. Okay. My next question is, what is the difference between these? What is the difference among the ODBC and the JDBC? Anyone? Yes, Larry, what you are trying to say? So main difference between the JDBC and the ODBC is that open database connectivity means that is open to any language. That may be C, that may be C++, that may be COBOL, that may be Fortran. Any language we are using in the ODBC. But in JDBC it is specified with the Java. That is the Java database connectivity. We are connecting the database with the Java only. In ODBC we can connect the database with any of the open source software, any of the programming languages. The next is the updatable cursors, then dynamic SQL, SQL functions, stored procedures, procedural constructs, external language routines, then trigger, that is the action that is performed, then what are the various actions that is performed before the triggers and after the triggers. Then transition variables in the tables, recursive queries, that means again it is repeated out, repeated out, repeated out. It is going on. Then again going on, again going on. So it is a revert back. That is a recursive query. The next one is the monotonic query. Then next one is the ranking functions. That includes a rank, then subrank. That is not in your course. Monotonic is also included in your course. Then windowing is not in your course. Then multidimensional data, that includes the measure attributes, dimension attributes, all that we have done. Then data cube, slicing and the dicing, roll up and the draw functions. So these are the various practice questions. Now next is formal relational query languages. That is the next chapter that I'm going to start within the next class, because only 10 minutes are left for the class and there is no way to start the chapter, new chapter in 10 minutes. Yeah, in this chapter we are using, or we are studying about the relational algebra in detail. So till now, any doubts anyone? Any doubts regarding the assignments, regarding the chapters, regarding any topic that you want to ask from any of the module? It is not that it is specified to the database, no. Any of the module, anything that you want to ask. Yeah, please submit the assignment over time so that we can issue the certificate to you. Yeah, it means you get cleared. So please submit the assignments well on the time. Alright. Any other queries? So thanks a lot everyone. We will meet with the new chapter, chapter number 6 in the tomorrow's class. Alright.